Let's take a look at some of the quiz solutions. There's some highlights I want to point out to you. For this first one, it says section 1.3 on your quizzes. I believe it's section 1.4. And it's working with the limit definition of a derivative, where you have to find f of x plus h, and then take f of x plus h and subtract the original function. So the common error here is putting something different here, or leaving off this limit as h goes to 0. So to run the limit definition, you have to write f prime of x, take the limit, simplifying, and then here, when you actually do the limit, you are crossing out any terms that have h in them because the h's are going to 0. So this whole thing goes to 0, and all you have left is 4x minus 3. Now you can verify that using the power rule. Bring the 2 down, 2 times 4, 2 times 2 is 4, 4x, negative 3x, derivative is negative 3. So you use the power rule to say, yes, that's what I have. But you have to use this actual limit, the entire limit piece. Now, when you look at the second piece, it's asking you to find f prime of 2, so you're just substituting in. All you're doing is getting a number. Now, what does that mean with respect to the graph of the original function? And it's the slope of the tangent line. And so when we look at these, we have another version of the same quiz. And so here, I'm just going to go real quickly so that you can see the solutions. It works the exact same way as the other one does. Now let's move on to the quiz that says 1.5 at the top. And it says no calculators. Remember, for the exam, you can use a scientific calculator only. For this one, it was algebraically simplifying, so you had to write as roots and then multiply in by distributing, and that's it. Once you get out here, then you x to the 0 is 1, simplify one more time. For number 2, finding the derivative of this is still catching people, so I highly recommend you separate it first, then take the derivative of this, which is just the coefficient. When you look at the next guy, find the points on the graph at which this is horizontal, so you want the derivative is 0. Go ahead and find the derivative using the power rule. You're not asked to use the limit definition, so use your shortcut rules, it's power rules here. Once you have that, set it equal to 0. When you set it equal to 0, solve for the x. That is the x at which this function has a horizontal tangent line. You need to have a point because they're asking for points, so go ahead and substitute back in the function again to get that y value. This kind of question can be find the point or find the x value. For the next one, what changes above if you change it to wanting to have a slope of 17 instead of horizontal? It means you're going to set that derivative instead of equal to 0, you're going to set it equal to 17, and then everything else is the same. Let me show you the other versions. So here is the other version, version B. And then next quiz 4.1, we're looking at antiderivatives here. Find a function. That means you need to have f of x here with some function, and they give you the derivative. So you have to put it within an integral sign. You cannot just show up with x cubed plus 1/2 x squared plus c. Even if this is correct, you can't just go from here to here. The operator is the integral sign in the dx. Remember, you lose 2 points out of 5. Here we set this up as 6 because there was extra pieces going on. But you're going to lose quite a few points if you forget that, because the only reason you're allowed to go from here to here is because of the integral sign. So that's one of the crucial pieces. We're using it all semester, and you'll get dinged for that. So you got to watch that. Once you find that antiderivative, you have c. We're looking for the whole function here. So now we got to find c. That means use the point they give you, x and y, write it as a point. The -1 are the x's, so they go in here. The y is 2. Remember, f of x is really just y, so that's a 2. Solve for c. Oh, you have to substitute in for everything except the c so that you can solve then for the c. Once you find that c, then you substitute them back in again. For this next one, determine this indefinite integral. You need to rewrite it algebraically first. You've got a variable with some kind of exponent on it. Rewrite it as a negative exponent. Now add 1 to the exponent, divide by the new exponent, don't forget the c. Now you need to check to go backwards, bring the -4 down, times -1/4 gives you 1, yes, subtract 1, yes, so you want to go this way and this way. For this guy, you get the same thing. It's nice, you add 1 to the exponent, get a 4, divide by the new exponent. The derivative of e to the x is e to the x. The antiderivative of e to the x is e to the x. It just bunny hops back and forth. The coefficient comes along for the ride. Do not separate this into two integrals, where integral of x cubed, integral of -3e to the x, both to the dx. Leave these things together. Don't separate them. Always have to be together. A couple of versions on this one. Here's the solutions to version B. You can pause the video to look at that more. And then here are the solutions to C. Pause it if you had C. Here it is to D. Pause that if you want to take a look at those. So that's it. Hope you're having a great day.